Hey guys, my name is Karthik Durg, and today in this demo, I'll be walking you through one of my very own Sherlock called GroundWorm, which is an attack simulation of SandWorm APT designed for defenders to get some defensive insights. Before we begin, uh, sorry, a little bit about myself. I'm currently working as a defensive content engineer at Hack the Box. I've been working here since 2+ years, and uh, I've been in this cybersecurity industry since 8+ years from different fields, starting as a blue teamer and going and becoming a red teamer. And some of the Sherlocks that I created for Hack the Box are like Superstar, Neural Noel, the ransomware that is in Optical Trace 5, Horse Panda D, Saboteur, Pearls, Popnet, and so on. So the scenario for this Sherlock is imaginary, as you can see it, and it's about how the Gotham's power infrastructure has have started their project called Project Sentinel, where they are simulating real world threat actors for defenders, and once they are done, they will be providing all the logs and all the attack logs and stuff like that to defenders to build defensive visibility. So with that, let's quickly move on to our hack the box console. Now that we have understood the scenario, we will get started with GroundWorm. And so, as you can see, that I have already answered a few questions which I cannot really undo. So we'll just quickly get started with task 1 to task 6. The first task goes like, which service did the attacker exploit to gain initial access into the Gotham's network? I have already downloaded the logs. It also comes with an instruction on how you can import the Windows event logs available in the Windows folder, and the Windows folder also contains the logs, the API logs. So the one that we are really interested for the first question is the Ubuntu logs. We'll quickly open all of them in a notepad. As you can see, like, it has several entries in each of them. So for the first question, we are really interested in the main log file, and as soon as we open it, we see that the Ubuntu was running exim 4.89, which is the exim is basically a mail transfer agent which runs as a daemon um, on the machine, and it is running on the port 25. So just like exim, there are many other mail transfer agent that have their own SMTP service implemented. And if you like to see the service, how the service is implemented for the exim mail transfer agent, so you can just go to the GitHub repository of exim and uh, look for this file under the source directory. Here you can see there is a lot of code, and you can also see some commands uh, to interact with the exim SMTP service. Going back to the log, here we can also see that there are some attempts made to exploit the CVE 2019 the answer for the first question is SMTP, straightforward, as it looks like, and as it is the only way to interact with exim. Sorry, as it is the only way to interact with the exim application using the SMTP service it provides. As you can see, going back to the challenge. SMTP was the right answer. So the second task is how many lines of data did the attacker send in order to exploit the above service. Again, quickly going back to the main log, we already have know which CVE is being exploited. So just to confirm, we can go to this repository and see what it has to offer to answer this question. I already have it here. So we click this. As you can see, like it's the same CVE, and the exim that we are running is vulnerable to the same. It has a lot of info on how we can install and stuff. We'll quickly scroll to the usage. So here you can see how exim accepts the hello request, which is how the exim does it. And in the data, we see that the author, or in order to exploit this service, will have to send 31 lines of data plus plus an empty line, you can say. So it's basically like 32 lines of data that you have to send. And as you can see, like the message ended here after sending 32 lines of data. So the answer for the task 2 is 32. The task 3 is what is the attacker's command and control IP address. We'll go to the same main log, and we do see, like as you can see, there are already several attempts to run the exploit. So if you scroll down, you can see like the attacker is trying to execute a reverse shell after the exploit, and just after the netcat command, we see an IP address here, and connecting to port 1337. So we'll copy this IP address. We will remove, change these hex to dot, and yeah, this should be the attacker's command and control IP, which is also submitted and accepted here. The task 4, what is the name of the file the attacker created to attempt to maintain persistency that would only work after reboot? For this question, we will open the bash history, as it contains all the command line arguments that were captured. It has a lot of lines, and as soon as we scroll down, we see there are several interesting ones. We see like there is some creation of a file called .tab, and immediately after that we also have attacker creating syslog.d.service. Here, so once the service file is created, we also see that it is being updated with the service, with the configuration in the service file, and once it's saved, it is being enabled using the systemctl command, and then configuring the system with the daemon reload command. So this means like the configuration was loaded, but it is not immediately effective, as in order to run it, the system has to first reboot, and that's when it gets executed. So yeah, the answer for this task, as you can see, is syslog.d.service. And during our previous analysis for task 4, we also saw that like the attacker was creating a cron job, which runs every minute, and it's a reverse shell that is connecting to the IP that we discovered previously. So yeah, the another persistency mechanism that the attacker has implemented. So The answer for the next question we already know or knew that, which is .tab file. So these are all the sandworm, sandworm techniques that were used during the attack on one of the power grid. I think the electric power grid. So this is quite useful if you would like to capture such events, and you can just go back and create rules in your monitoring system. So the task 6 is the attacker successfully accessed confidential system file on Linux. What is the file's name? So immediately after running, reloading the daemon using the systemctl command, we also see that attacker is trying to, or has waived the shadow file. And in the entire log, like, this is the only like confidential file that they try to waive, or they have waived. So the answer for the task 6 is pretty straightforward. It's a shadow file. The next task, which is the task 7, the attacker successfully cracked the secret data obtained from the above file, which computer was first targeted for lateral movement. Just like how the sandworm did it, it's the same scenario here, and the way we can do this is, so I have already loaded the event logs inside Splunk, inside my Splunk instance, so you guys can follow the instructions when you are working in your own lab to do the same. So let's assume this scenario that you start your day as a blue teamer, and you just go and sit in front of your any of the log analysis, or Elasticsearch, or like Splunk instance, or anything like that, and you go and you cannot just start looking at every event IDs and look for suspicious logs. It's very tedious task. So as a blue teamer, what I used to do when I was working as a blue teamer was just go there and start look for all the PowerShell logs that are running in a hidden window. So this would actually give me a lot of malicious or suspicious activity that is happening in the environment. So and most of the time it used to be very true. I used to get all the true positive alerts, and the only time when I never got was when I was alerted that there was some maintenance or some configuration changes being done by the administrator of the organization. So with that, we will just hit the search button. So this is actually Splunk bad practice. I mean, we cannot just do this in a huge in an organization that has huge number of logs. It's just that since I have imported the logs, I cannot. The Splunk is not able to parse the command line arguments. So here I have very less logs, so we can just follow this method here. So when you're working on your own Splunk instance in your organization, please do include the proper fields so that your search is faster. Okay, so when we do this, we see a lot of suspicious events happening that are logged by the event that are logged in the event log. We also see, like, there are two hosts, there are two computers that are running this. To get the first computer that that executed this suspicious PowerShell activity, we will just do sort _time to list them in a um, yeah, descending order, ascending order. um, so yeah, as you can see, the first machine that executed this PowerShell was desktop Batman, and this should be our first answer. So let's try submitting this. Okay, it's without the domain. Okay, great. uh, we have our first the computer, the first computer that was targeted for the lateral movement. um, and let's now that we have the computer that was targeted, so the next question is, what is the attacker's internal IP? So we already have the first, you know um, computer that was targeted. So we will do source uh, win event log security, and let's say computer name, maybe, or host. We can just say, yeah, computer name equals desktop admin city, and we can just hit enter here, or we'll just hit the search button. Yeah, we get a couple of logs. So let's look at source IP. Okay, we do see like a couple of IPs, but these two, as we know, like they are local host. We only have one source IP, that is that it's coming from the incoming commission to this computer is coming from. And so let's just expand the log, and we see that an account logon was logged on. So uh, so this should be the attacker's IP address, since this is the only connection over here that is interacting with Batman. And yeah, we can also, let's say, try searching something like this. If let's see if can see any other event logs. Okay, yeah, yeah, that's the right one. um, so yeah, we have a logon ID as nil. Yeah, this definitely looks suspicious. So let's try submitting this for the answer for the task 8. Great. So this is the right answer for task 8. Now that we have the IP address, so the next question is like, what is the logon ID associated with the attacker's initial login to victim machine? Okay. So we do have everything right now. Like we have the desktop, the computer name, uh, the first victim of the computer name of the first victim, the source IP address. Here, this we can also do the same thing here. Let's say, let's sort time. You can say, or something like sort time minus. So as we go down, like we do see like it's in a descending order. And if you just directly go scroll down, we see we can see the login ID here. So the last log would be the first initial attempt made to log into this computer. So let's submit this. Okay, perfect. Yeah, so we are now done with task 9. So the next task is which Windows administrative feature is responsible for initiating the suspicious PowerShell execution? Here we will follow the same practice that we did, like searching for the hidden PowerShell command, like PowerShell running in a hidden window, um, and see if we can find anything interesting. Uh, we can also do like again filter out the logs. So yeah, I think we do not have the parent process here. uh, it would just ease up our method of finding the 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 parent process that is responsible for doing this. So we do have, like, we do have something called as message. So let's see if we find anything interesting in message. Yeah, okay, perfect. So here you can see like in the message section, let's just filter it out and expand the logs. Okay, so here as you can see, the PowerShell that is running, and this is actually the parent process that is spawning the cmd.exe, and this cmd.exe is running the malicious PowerShell script. So this wmi.prv.se.exe is nothing but a process that is linked to Windows management instrumentation. So yeah, let's submit the answer. Okay, perfect. So as you guys saw, like how this this CMD is getting spawned from PowerShell.exe. So this looks like some kind of lateral movement uh, via some tool using that is targeting the WMI of this machine. So let's move on to our next question to find it out. So the task 11 is which toolset did the attacker utilize during lateral movement? So we'll go back to our Splunk instance, and here we have been seeing a lot of PowerShell, and the encoded PowerShell that is being executed. But if we closely look at how it is being executed, we see that it is first using cmd.exe with a following switch, and then it uses some command, and then it outputs the command, the output of the command that was executed to a share over here. So let's see this behavior. Just go and Google this behavior. Let's say lateral movement. So immediately we see a lot of blogs that come up. So we'll just click on the first one, and yeah. So as soon as we click this, we immediately come across the Python's the in packets WMI exec the WMI exe script that was actually uh, that actually has this behavior. But in order to understand how this is executed, uh, we'll have to see how the command is actually running over here. So as you can see, that the WMI exec first executes the command and outputs its the output of that command to share that was created by impacket. So here what impacket is doing is when you run the wmi.exec.py, it actually it first starts the SMB server using SMB server.py that is available in impacket, and then executes the command, and then the output of that command is sent to the attacker that is hosting the SMB server. So if we just say WMI exec is the answer, that's not right, because here SMB server.py is also involved. And let's look have a deep look, like a the proper look at this in a diagram. So in packet is a collection of classes, and once the attacker executes it, it creates a attacker share using smb server.py, and then executes the command, and then it outputs it back to the smb server that attacker created. So here WMI exec is not just a standalone tool. It relies on smb server.py, and again this script relies on other internal classes of impacket framework. So that's why the answer for this question should be impacket. So let's submit it. Yeah. So now we will move on to the next question, that is task level 12. Which Win32 API was utilized by the above process to execute the attacker's command line? So we have the API logs, and as we know that WMI prvsc.exe was executing this thing, we will go to we will just expand the process and click on wmiprvsc.exe to just narrow it down to what this process actually executed. We already know that it was executing cmd.exe, or we can also search for PowerShell. Um, okay, maybe, yeah. Okay, so as you can see, the create process user w is the one that is actually responsible for creating a process and executing this these commands. So the answer should be create process as user w. Let's submit this. Perfect. With that, we'll now move on to task 13, which Win32 API was used to hook the keylogger procedure to the user's keyboard. In the same captured logs, we have a lot of other command cmd.exe running. The one that looks like a keylogger is the process called log.exe. And again, clicking on this will give us all the API executed by other modules. So we will just narrow it down to log.exe, and as soon as we narrow it down, it only lists us what the API Win32 API triggered by log.exe. So as soon as we see it, we come across a very well-known API for keylogging, and here we see that in the second argument is the one that is a procedure that is stored in some random address is hooking wh keyboard underscore ll. So let's this should be an answer for the task. Let's try submitting it and see if it gets accepted. Yeah, perfect. So with that, we will now move on to task 14. Successfully captured the administrator's credentials. What was the captured password? So for this, we will go back to our API monitor tool and click on keylogger, the process log.exe. And here we already saw in the previous answer that it was set Windows hook that was initiating, you know, the procedure. And just after the set Windows hook, uh, we see that there is an empty write file API being called, and we can also see that it is writing stuff into the file. So we'll just follow this API, and you can see there are some letters and some hex buffer translating to some letters. So as we follow it, there are a lot of empty write file APIs that are being called over here. So I've already copied all the hex buffer here, and we can just recreate the file using hex editor. File, copy and paste it, save as some, yeah, test.txt. So we'll open the text file, and yeah, here we can clearly see that attacker has captured the credentials, and the password over here is p2ssword1. We will just paste it, submit the answer. Okay, right. So uh, why P2SS, I mean the captured password is the right answer. What actually happened during the simulation was the victim typed the password that was typed during the simulation was p at ssw0rd1, and the backspace and 2 that appears after after the password is completely from a different uh, action. So if when an user does that, that doesn't mean he the keylogger is actually deleting the text from log.txt. It's just logging it continuously, and also there is no uh, indications that one was erased from the log.txt. Um, the takeaway from this question is the simulated technique is input capture, keylogging, and this is what the SandWorm used during in its binary. And a flawed output doesn't mean the capture was failed. So, in terms of attackers' terminology, when we say the attacker has successfully captured it, it means the attacker has uh, captured the credentials, or all the data that user was inputting into. And the intent of the goal of this Win32 API is to show how anti-write file provides clear visibility into what the attacker actually captured, and monitoring it also enables defenders to assess what was actually exfiltrated from the victim machines. So yeah, that's for the task 14, and we will now move on to task 15. List all the confidential files that were encrypted by the ransomware in order that they were encrypted. Um, so we have two API monitor files. Uh, we will open this for the DC API monitor file, and we will just hover over the run.dll32.exe, and we see that the run.dll32 has executed a file, I mean, has loaded a DLL with file called perfc.dat, and it has then executed a function within the DLL. So we'll look for this perfc.dat. We'll click on this just to narrow down what it has actually executed, and as soon as we open it, we see some files here uh, that were actually being accessed with a create file a API, and it was then encrypted. So I think these are the three files that the attacker has encrypted. I already have all the names of three files. We'll just submit them as the answer. The task 16 is which Win32 API is used to encrypt the files mentioned above. So previously we saw that immediately after accessing the contents of the file via create file API, so the file is being encrypted, and it is then being saved with a .enc extension. So the API that is encrypting the file is crypt encrypt. So let's submit that. Encrypt. Okay, perfect. So the last question for this Sherlock is submit the 16-byte hex key that was used for encryption. So we already know that the Win32 API is being used over here belong to the WinCrypt header file or the WinCrypt library. And whenever this is being accessed, there are two ways the program can generate keys. One is using the cryptgen, and the other one is using a uh, crypt import key. So here we already see like the program or the attacker used crypt import to import the key, and immediately when we click on this, we see a hex buffer here that says dead beef and dead beef 4 times, which is 16 bytes. So yeah, let's submit this as an answer, as I've already you know copied all the hex buffer and you know re-entered it as a raw byte as you submit it in your when you're coding in the array. So we'll just submit this. Perfect. Yeah, that's the groundworm Sherlock. The key takeaway from this last question is uh, capturing getting to know how this crypt import key works, and how you can actually extract this valuable encryption key from this file is let's say if a machine is infected and the endpoint security is actually monitoring this this API. You can actually capture this key and later use it to decrypt all the encrypted files that when the victim is infected, and you can use these keys to actually decrypt them. So that's how valuable it would be if we can monitor crypt encrypt key. So yeah, I mean, again, not just encrypting it again with a lot of conditions, but yeah, it does contain valuable information. So that's it, guys. Thank you so much for staying with me on this, and giving me some valuable insights for this challenge. I have definitely learned a lot during when I was creating this, and I hope you guys have also learned from this. So yeah, please feel free to message me on Discord. It's I4MR00 root. So yeah, thank you so much.